Be welcome to this new documentary. I am the Engineer Hiddekel Morrison, and I appreciate you decide to see this educational content, in which we will see the most distant star ever observed, the latest and most exciting contribution from the Hubble Space Telescope, with new data, discoveries, and stunning images. From an engineer's perspective, we start. This iconic space telescope called Hubble, from the United States Space Agency, NASA, has set an extraordinary new benchmark, detecting the light of a star that existed in the first billion years after the birth of the universe, in the moment of the great explosion known as the Big Bang, which makes it the farthest individual star ever seen to date as officially reported by NASA in this statement. This new milestone is the most recent contribution of the Hubble Space Telescope, or simply Hubble, the best-known space telescope in modern astronomy that orbits outside the Earth's atmosphere, in a circular orbit around planet Earth at 593 kilometers above sea level. This new Hubble find is a huge leap back in time that surpasses the previous star Hubble detected in 2018. That previous star that Hubble had discovered existed when the universe was about 4 billion years old, or 30% of his current age. Let's see in detail what was reported by NASA, with revealing information about this new record in space exploration. But first, I ask you to support us by liking this video, sharing this video with your contacts, and subscribing to this channel, turning on notifications, so with your support, we can continue to frequently generate interesting documentaries on aerospace technology and the universe. Thank you for contributing to the creation of educational content. This newly discovered star should not be confused with the oldest known star, also discovered by the Hubble Space Telescope in 2013. This new star is the farthest so far. It was captured 13,000 million light-years away. That means that if we wanted to get to where that light was detected, we would have to travel for 13,000 million years at the speed of light, which is approximately 300,000 kilometers per second. This detailed view highlights the position of this new star named after Earendel, seen along a ripple in spacetime, dotted line, that magnifies it and makes it possible for the star to detect it at such a great distance, almost 13,000 million light-years. Also indicated is a star cluster that is reflected on both sides of the magnification line. The distortion and magnification are created by the mass of a huge galaxy cluster located between the Hubble telescope and the star Earendel. The mass of the galaxy cluster is so great that it warps the fabric of space, and looking through that space is like looking through a magnifying glass. Along the edge of the glass or lens, the appearance of things on the other side. It is distorted at the same time that it is magnified. This newly discovered historic star is so far away that its light has taken 12.9 billion years to reach Earth, and it appears to us as when the universe was only 7% of its current age, at a redshift of 6.2. Scientists use the term redshift because as the universe expands, light from distant objects is stretched or shifted to longer, redder wavelengths as it travels toward us. The smallest objects previously seen at such a distance are star clusters within early galaxies. The discovery was made from data collected during the Hubble Space Telescope study of gravitational lensing ionization in clusters program. After scientists studied the galaxy in detail, it was determined that one of the elements is a newly discovered extremely magnified star named Earendel, which means morning star in Old English. Discovery promises to open an era in the exploration of very early star formation. Scientists understand that such a star existed so long ago that it may not have had all of the same raw materials as the stars that surround us today. Studying Earendel will be a window into an era of the universe with which scientists are unfamiliar, but which led to everything science knows about the universe today. The research team estimates that Earendel is at least 50 times the mass of our Sun and millions of times brighter, rivaling the most massive stars known. But even such a bright, high-mass star would be impossible to see at such a great distance without the help of natural magnification produced by a huge galaxy cluster between us and Earendel. The mass of the galaxy cluster warps the fabric of space, creating a powerful natural magnifying glass that greatly distorts and amplifies light from distant objects behind it. Thanks to the rare alignment with the cluster of galaxies serving as a magnifying lens, the star Earendel appears directly on or very close to a ripple in the fabric of space. This ripple, which is defined in optics as a caustic, provides maximum magnification and brightness. The effect is analogous to the rippled surface of a swimming pool, creating patterns of shimmering light on the bottom of the pool on a sunny day. Ripples on the surface act like lenses, focusing sunlight to maximum brightness at the bottom of the pool. This caustic makes the star Earendel stand out from the general glare of its home galaxy. Its brightness is magnified 1,000 times or more. At this point, astronomers cannot determine if Earendel is a binary star, although most massive stars have at least one smaller companion star. Astronomers expect the star Earendel to remain highly magnified for years to come. It will be observed by NASA's new, modern and powerful James Webb Space Telescope. Webb's high sensitivity to infrared light is necessary to learn more about Earendel, because its light is stretched, redshifted, to longer infrared wavelengths due to the expansion of the universe. With Webb, it is hoped to confirm that Earendel is indeed a star, as well as to measure its brightness and temperature. These details will narrow the investigation of its type and its stage in the stellar life cycle. We also hope to find that the arc of dawn lacks the heavy elements that form in later generations of stars. This would suggest that Earendel is a rare, massive, metal-poor star. The Earendel composition will be of great interest to astronomers, because it formed before the universe was filled with heavy elements produced by successive generations of massive stars. If follow-up studies find that Earendel is composed of only primordial hydrogen and helium, it would be the first evidence for the legendary population 3 stars, which are supposed to be the first stars born after the Big Bang. Science is looking forward to the formal start of operations of the new James Webb Space Telescope, which will be able to see stars even further away than this new Earendel, which would be incredibly exciting. Science will be able to go as far back as they can, so the James Webb Telescope is certain to break the distance record for this new Earendel star. The Hubble Space Telescope is an international cooperation project between NASA and ESA, European Space Agency. NASA's Goddard Space Flight Center in Greenbelt, Maryland, manages the telescope. The Space Telescope Science Institute, SCI, in Baltimore, Maryland, conducts Hubble science operations. SCI is operated for NASA by the Association of Universities for Research in Astronomy in Washington, D.C. As usual, we appreciate you informing us. It is a real pleasure to be able to provide you with the main news, trends and developments about the most important aspects of aerospace technology and the universe, from the perspective of an engineer. I am the Engineer Hiddekel Morrison, and I invite you to meet again in a future installment.